All right, everybody, welcome back. We're going to jump all the way down to slide 33 in the Unit 8 PowerPoint and the Unit 8 notes. Okay, if there's time, we'll go back and cover variation. But right now, we're going to start with simplifying rational expressions. Okay, and again, rational expressions, okay, ratio or fraction. Okay, so, all right, in order to simplify a rational expression completely, okay, and again, key word here is completely, we must factor. Okay, so all of you who hated Unit 4, okay, we're going to come back and we are going to turn into factoring machines. That way we can simplify the monomials using the exponent rules, which is step 2. Okay, basically that means we're going to cancel out giant ones. All right, so if it's the same thing on the top with the same factor on the bottom, we can cancel it out. Okay, and then lastly, we're going to reduce the common binomial factors. Okay, and one thing I'm going to add here is domain restrictions. Okay, since we're dealing with fractions, we are not allowed to divide by 0. So we need to say what x is not allowed to equal in the denominator only. Okay, so you'll see exactly what I mean when we start doing some examples. Okay, so it's only a few pages here of notes, and then we'll have an opportunity to practice. Okay, all right, so here we just have some basic laws of exponents here for question number 1. All right, so we're going to reduce the coefficients, okay, and then we're going to reduce the common bases. Okay, so 20 over 14, we can pull on a factor of 2 there, okay, and that reduces to 10/7. And then laws of exponent state, when we divide, we subtract the exponents. Okay, so 6 minus 2 is 4, and the extras belong on the top. Okay, so there's our final answer. However, we have this variable in the denominator. If that x would be 0, okay, that would turn the entire denominator into 0. So we're not allowed to equal 0. So you're going to see me throughout this practice stating the domain restrictions in my final answer. Okay. All right, so there's the first one. Okay. Question number 2. All right. So this one here, 6n minus 72 over 12n plus 24. We can't do this. We can't just divide these. Okay. That entire numerator is one expression, denominator is one expression. So we can't simplify it in parts over addition or subtraction. Okay. We need to break it apart into factors. Okay. So what's the GCF in the numerator? Okay, there's a factor of 6 hiding in there. So that's going to be 6 times the quantity n minus 12. Okay, and our denominator has a common factor of 12. So we pull out the GCF of 12 and we get n plus 2. All right, so here the only thing that we can reduce is this. Okay, 6/12, that reduces to 1/2. Okay, so our 2 goes in the denominator. We don't have to put a 1 upstairs because we have the n minus 12 up there. Okay, and then lastly, n plus 2. Okay, and x is not allowed to equal -2. Okay, so it's very important we put that domain restriction in there. All right, pretty simple. All right, let's continue on here. All right, we see that we have something here. This is the difference of squares. Okay, we have a perfect square minus a perfect square. So we can use our factoring shortcut to turn it into 7 plus x, 7 minus x. Okay, over the denominator of x plus 7. Now we're looking for the same thing on the top and the bottom. This is where that giant 1 comes into play. All right, so the order of this doesn't matter. Okay, we can flip-flop these, x plus 7, same as 7 plus x, and I have that common factor in the denominator, so I can eliminate those, okay, because that's like multiplying by 1. So your final answer here would just be the quantity 7 minus x. However, okay, since this was part of my original, okay, I have to state the domain restriction. Even though it's not in my final answer, okay, I still have to state the domain restriction from the original. Okay, so x is not allowed to equal -7. Okay, that's very important. A lot of times people only do the domain restrictions for their final simplified answer. Okay, but we have to do it from the beginning. All right. All right, the next one to the right here. Okay, we see p squared minus 3p minus 28 over p squared plus 7p plus 12. This is a common mistake of doing this. We cannot simply cancel out the p squareds. Okay, instead rewrite it as a product of its factors. Okay, so if we factor the numerator here, what multiplies to be -28 and adds to give you -3, right? And that is +4, -7. All right, for our denominator, same thing. What multiplies to 12 and adds to 7, and that's 3 and 4. So +3 and +4. All right, so now we can look at this and look for common factors. Okay, our common factors here would be the p plus 4s. Okay, so what remains on top is p minus 7. What remains on bottom is p plus 3. However, x is not allowed to equal, I shouldn't say x, p is our variable. P is not allowed to equal -3 here or -4 here. Okay, so there's your final answer. All right. All right. Now, when we look here, we have multiplication in the middle. Okay, right there, there's a multiplication symbol. Okay, everything on the numerator, when we multiply it out, is going to stay in the numerator. Everything multiplied in the denominator stays in the denominator. So there's a couple different ways we can simplify this. Some people like to turn this into one giant expression and then simplify it. Other people like to do it in parts. Okay, I'll show it both ways, and then you can decide which way you want to do it and how you want to do it and stay organized. So we're going to multiply coefficients with coefficients. So 4 times 15 gives us our 60. And then multiply your x's, x cubed, x to the 4th, we add them. So we get x to the 7th, and then y squared is by itself up there. Do the same process for the denominator. 6 times 12 is 72. And then x squared is by itself, y cubed is by itself. Now it looks like one of the first questions we just did. We just have to simplify its parts. Okay, so 60 over 72 has a common factor of 12 in it. All right, so if we yank a 12 out of both, that reduces to 5/6. And then you simplify your exponents with common bases. So 7 minus 2 is x to the 5th on top. And then 2 minus 3 is -1, so the negatives go in the bottom. I always like to say, where they're more, put the extras where they belong. Okay, there's 1 extra y in the denominator. Okay, so for here, x is not allowed to equal 0, and y is also not allowed to equal 0. Okay, now the alternative way to do this, let me rewrite our original problem. Some people like to simplify this a little bit differently. They like to say, okay, well, 4/6, okay, that reduces to 2/3. Okay, 15/6 also has a 3 in it. Okay, so that'd be 5 over 2. Okay, so that's gone. And then this 2 would cancel with that 2. Okay, so that's gone. All right, so I'm going to cross out everything that I no longer have. Okay. Okay, let me go back here. I think I miscopied the problem. I did. Okay, this should be a 12. My fault, everybody. Okay, so again, 4/6, okay, reduces to 2/3. Okay, 15 over 12, each contains a factor of 3. Okay, so if we pull a 3 out of each of them, that turns into 5/4. And then we could reduce the 2/4, okay, to 1/2. All right, so now if we look at our coefficients, in the numerator, it's only a 5. Okay, and then you can combine your exponents accordingly. Okay. And then our 3 times our 2 is our 6. And then that's x to the 4th y cubed. And then you can clean up your variables. Okay, some people like to clean up their variables over here. All right, say, oh, well, 3 and 2, all of these cancel, which leaves 1. Okay, it does get kind of messy. It's a lot to keep track of in your head. But some people can do it, some people can't. That's why the first way, if you just make it one giant problem, you can just reduce it one time. Okay, it's up to you. Okay, same thing, our domain restrictions, x cannot equal 0 and y cannot equal 0. Okay, that would be part of your final answer. All right, now we throw division at you. So instead of dividing by fractions, we multiply by their reciprocals. Okay, so I'm going to rewrite this, 5pq over 16p cubed multiplied with, and again, I flip this and multiply. Okay, so you're almost forced to rewrite this just to stay organized. All right, so once again, you might look and say, well, you know, the 5 and the 35 each contains a 5, so you pull a 5 out of them. The 8 and the 16, you pull an 8 out of them. Okay, you could do it that way. I'm going to multiply everything out instead and show you that way. All right, so our 5 times our 8 for our numerator is 40. And I have 1p and then q to the 6th. And our denominator, 16 times 35 is 560. And I have p to the 5th and then q squared. All right, now I just have to clean up my coefficients, my p's, and my q's. Okay, so 40 over 560, if you're not sure what's in there, okay, you could always type in your calculator and reduce the fraction. It turns into 1/14th, okay, because there's a common factor of 40. Okay, 1/14th. All right, and then do your p's. Where are there more p's in the denominator? How many extra? 4. And then q to the 6 over q squared is q to the 4th. Okay, and I don't technically need a 1 here because I have something in the numerator. All right, do your domain restrictions. P is not allowed to equal 0, and q is not allowed to equal 0. All right, and that would be your final answer. A lot of what we get into now, okay, some of these questions look extremely intimidating because they're very long, all right? But once again, if we break it into a product of its factors, into its smaller parts, we can see how things cancel out and disappear, all right? So you just have to kind of do one thing at a time, all right? So we're going to start with the 10v minus 5v squared. What do we have in there, okay? 5v is our greatest common factor, which leaves 2 minus v. All right, and then we can do this one. It doesn't matter what order as long as you keep it in the location it belongs. All right, v squared minus 11v plus 18. So what multiplies to 18 and adds to negative 11, negative 2, and negative 9. All right, now this multiplication here, okay, just means everything that's up top stays up top. That's because we multiply across. All right, so we're just going to continue up here. What multiplies to 9 adds to negative 8, negative 9, positive 1, and then we have a 15v in the denominator. All right, so now my recommendation is to do your domain restrictions before you cancel them out. That way you don't leave any out by accident. Okay, so what in this factor, okay, can't equal 2, can't equal 9 for this guy, all right, and then we can't equal 0 here. All right, so you can put all those in there, 0, 2, and 9. I just put them in numerical order, and now we go to the chopping block. Okay, so what do we have that's the same in the numerator and the denominator? Okay, this one's obvious, v minus 9. All right, here's a v. I can cancel with this v. All right, if you want to reduce your 5 over 15 is 1/3. All right. And then we see these two kind of look alike, don't they? All right. What do we notice about them? They're actually opposites. So I'm just going to rewrite this just to show you. And we already took care of that. It turned into a 3. Okay. If we look at this a little closer, okay, I'm going to highlight them. Okay, these are opposites of one another. So it's technically a giant -1. All right. If we would rewrite this and pull on a -1 from our numerator, just this factor alone, okay, that would flip the signs -2 positive v. Okay, if we put it in standard form, always lead with the coefficient writing in descending order. Okay, that'd be v minus 2. V plus 1 is already there, over 3 times v minus 2. And then you'll also recognize that we have this v minus 2. All right, so your final answer is going to be -1 times v plus 1 over 3 with our domain restrictions. All right. The more of these you do, obviously, the better you get, and you recognize things like that. From the jump, you might see that what we have circled up here. I'll highlight it. Okay. Oh man, they're opposites. So you just cancel them out and make a -1. Okay. That would be acceptable as well. Okay. Here's the last one we're going to do. Okay. And we kind of threw a curveball at you there with the whole division thing. Some people want to flip it and multiply. Okay. That's what we have to do. But I'm going to break this down and then flip it and multiply all in one step. Okay. So if we do that, factor first. Okay. We factor this. We notice that there's a 2x squared hiding in both of them, which leaves an x minus 6. Okay. If we look at the denominator next. All right. What multiplies to give you -12? But add to give you -4. Okay, so that would be -6 and +2. Now, be careful here because I'm actually going to do this one because it's going to go up top. All right, I'm going to do that one first and put it in the numerator. So what multiplies to 15 and adds to give you -8? -5 and -3. And then my denominator was my numerator, okay, but that's going downstairs. Okay, what's in common between a 24x squared and a -8x cubed? Each of those contains an 8x squared, all right, which leaves you a 3x minus 1. Okay, nope, I'm lying to you. Gives you a 3 minus x. Yeah. Okay, so now that we have everything factored, we have the division turned into multiplication. Okay, if you have to rewrite the line and then factor it, do it just so you have everything in the correct location. All right, like I mentioned before, it doesn't hurt to do your domain restrictions before we start canceling giant ones, common factors. So x can equal 6 there, -2. A lot of people forget about that x. X can equal 0, and the last one, x can equal 3. Okay, so we'll include all those in our final answer. Now let's go cancel giant ones. All right. So we have a factor of x minus 6. We have an x squared. All right. And if we look at this again, here's another one of those situations where we have the opposite. So that's technically a giant -1. So I can cancel that out and put a negative out here for that. All right. So just be cautious with that. And again, I already showed you, we can rewrite either the top or the bottom by pulling a negative out and make it -3 plus x. Okay. And then we can see the x minus 3's cancel, and then our -1 is still there. Okay. So I just put that up top right there so I wouldn't forget it. All right. The last thing we have to worry about is our coefficients. Okay. 2/8 reduces to 1/4. fourth. All right, so just keep track of all your simplification. That way when you do your final answer, we don't have a silly mistake somewhere. Okay, so let's see what we got left. We have a negative in the numerator. That's gone, that's gone, that's gone. And x minus 5. Okay, and then that's gone. Our denominator contains an x plus 2 and a 4. All right, that's gone. That turned into 4, that's gone, and that is now gone. Okay, don't erase anything, just simply cross it out and again, know that it's canceling out with a common factor in the numerator to form a 1. All right, so your final answer is that expression there, and then we include our domain restrictions. Okay, we tend to put these in numerical order: -2, 0, 3, and 6. Okay, so basically, guys, the moral of the story here to simplify rational expressions is exactly what the directions above here say. Okay, we must factor, factor, factor everything completely. And then step 2, okay, use your exponent rules, okay, eliminate giant ones, and then obviously reduce everything at the end. And lastly, state those domain restrictions. Okay, so you'll have an opportunity to ask questions when you come back to class, and we'll practice some of these. Again, as much as we hated chapter 4, every chapter we have referred back to our factoring skills. So, you know, as teachers, we stress the very importance of Unit 4, and that is kind of the foundation of Algebra 2. Everything comes back to those rules. Okay, so continue to practice, continue to get comfortable factoring, and then this process is actually very simple.